Act like somebody's always out to get you.
Because they are.
In this video, we will continue our series on security in AWS. We will configure a third-party firewall called pfSense. In a previous video, I discussed the importance of having layers of security, because if an actor is able to penetrate one layer, they will get stopped at the next layer or the one after that. Another cloud security practice is the use of third-party firewalls like pfSense. This provides more granular and tighter controls, plus the ability to take advantage of in-house skill set. Before we launch the firewall, there are a few things that we need to do. We will need to create a new VPC, 2 new subnets, and an internet gateway. One of the subnets will be behind the firewall and one in front of the firewall. In the old days, when everything was housed in our own data centers, we would call these internal networks and external networks. Internal meant everything inside of our offices. External was pretty much anything out on the internet. That's at a high level because there are also DMCs, extranets, and other less trusted networks. It might not make a whole lot of sense when we are talking about a cloud environment because technically speaking, everything is external to our infrastructure. It might be more common for you to refer to these as private or public networks. But even that is not 100% accurate because your office network is also a private network. Your small Wi-Fi network at home is also a private network. So in this video, I will refer to them as external public and internal private. Let's launch a new PVC and give it a name so we can identify it as we go along. It can get difficult to identify VPCs without a name. I'll call this one Firewall Tutorial and assign an IP address block of 10.1.0.0/16. Everything else will stay at default. Everything else will stay at default. Step number 2 is to create 2 new subnets. These need to be within the IP address range of the VPC. I will create subnets and give them names that will help me understand their position. I will use internal private and create subnet 10.1.1.0/24. I will also add subnet 2 and name it external public with a subnet of 10.1.2.0/24. If you are following along, make sure to either use the same names the first time you do this or come up with a naming convention that will identify the relative position. From my other video, you will recall that all VPCs also need an Internet Gateway or IGW in order to have access to the Internet. So let's create one. Let's call it pfSense Tutorial. Then we attach this to the new VPC. In my case, it's the only one available, even though I have several VPCs. Do you remember why? It's because you can only have one IGW attached to one VPC. All the other IGWs are already attached to other VPCs. Now let's launch the firewall. We can either go to the EC2 menu, or even better, we can search for pfSense. The search bar allows us to search in the marketplace. If we search for pfSense, it will give us the only option, which is NetGate pfSense Firewall. This is not free software. We will have to subscribe to this, and there is a per hour fee for the pfSense license and a per hour instance fee. NetGate gives you a 30 days free license, but you still have to pay AWS for the EC2 instance. Although you can launch pfSense on a T2 micro instance, which is also free tier eligible. We have to remember to select the region where we created the new VPC. In my case, this was the US West Oregon region. Then we select to launch this from the EC2 menu. Select the new VPC and the external public subnet because this will need an external public IP address. Everything else will leave at the default. The marketplace launch script also includes the correct ports that we want to open on the security group. Accept this and launch. Sit back and wait for this firewall to launch. One thing to note is that pfSense firewall instance protects a single VPC. The public subnet's default gateway is the AWS Internet Gateway. Most firewalls have at least two interfaces which separate internal and external networks. We want all traffic to transit through the firewall so that our security policies can be enforced. Per default, EC2 instances are launched with one interface. You can add more interfaces as you configure the EC2, but for this video, we will add a network interface after we have launched the EC2. Now that our EC2 is running, let's create a new network interface, ENI. Let's assign this to the internal private subnet and assign it to the default security group. Once the network interface is created, we have to attach it to the pfSense EC2. This is the way we make sure that the firewall has an internal and an external interface. It's good practice to give the interface, or ENI, a name. I will name this one Firewall Internal. We now have to create two route tables. Remember, internal traffic has to route through the firewall to get out to the internet. External traffic has to route through the firewall to get to the internal devices. We don't want to circumvent the firewall for any reason in any direction. In addition, the firewall needs to know how to get to the internet as well. Let's modify the route table that's already there and add the default route through the IGW. We then have to associate subnets to this route table.
Please take a moment and hit that subscribe button.
Ensure that we pick external public, as this is the external route table. I also renamed the route table so I can clearly identify it later on. Create another route table. This one is used to route internal traffic through the firewall. For this, we just need to add a default route. The internal route table should route everything through the network interface we created earlier. We also need to associate the internal subnet to this route table. Here it becomes evident why we need to give descriptive names to everything. One often forgotten step is needed. We need to go to our pfSense EC2 under Networking and Interfaces. Let's find the internal network interface. And we select it and select the Actions drop-down list. Select Change Source Destination Check and disable it. Save it. Now let's go to the pfSense dashboard by opening a tab and going to the public IP address. But wait, what is the default username and password? This is very hidden, and here I'm going to show you where to find it. Select the pfSense EC2, go to Actions, Monitor and Troubleshoot, and Get System Log. Here you will see the password towards the top. Let's try this. Enter admin and the password we copied. It works, and now we can let the wizard go through the initial steps and it will reload. Next until you get to the admin password screen. For this tutorial, I just copied the same password. Let the wizard complete and click Finish. Our firewall is installed. But we still need to configure it, and there is a lot to configure. One of the first things that we want to do is enable the secondary interface, which represents the internal/private networks. This is the network interface we created earlier. We also need to create an EC2 instance in the internal network. I'll speed this up as you already know how to launch an There are many tools that we can use to test connectivity. We can run a ping from the dashboard. Pings are 100% unsuccessful. Can you guess why? This pfSense firewall interface is on the internal network, so it is highly unlikely this firewall. We didn't touch the AWS Network ACL, which allows all by default. The culprit is probably the security group. Let's check our security group. Yes, it is only permitting SSH. We'll need to add ICMP, then this time, pings are successful. By default, traffic will source from the closest interface, so we need to make sure that we can get to it from the WAN interface. Let's pick the WAN interface and run some pings. Awesome. We are successful all the way, and the source address matches the address of our EC2. The internal EC2 we created is not directly accessible from the outside world, so we need to SSH into our pfSense first and then SSH to the internal EC2. I have already copied my SSH keys into the pfSense, and you will have to do the same either via the pfSense dashboard, WinSCP, or any other file transfer method that you use. I will run WordPress in Docker on the internal EC2 and attempt to access from the internet. For this example, I will run WordPress on external port 81 because 80 is being used by pfSense. I run a couple of Docker containers, one for the database and one for the WordPress installation. Run Docker PS to make sure they are up and running. And they are. Let's see if we can access the WordPress site by specifying port 81 with the external address of the pfSense firewall. It doesn't seem like it is going to work, and we time out. Can you guess why it is not working? There are actually several steps that we need to take. Placing a firewall in between internal and external networks is a lot more complicated than just spinning up EC2s in a default VPC. One thing that we have to do is create a port forward rule in the pfSense firewall. For this, we go to the firewall menu. And select NAT. We have to specify that the port we want to forward is port 81, and we have to put the IP address of the EC2 on the internal network, which is running WordPress. Now that we save and apply this, can we access? Nope, we are still unsuccessful. Can you guess why? Let's find out. With firewall rules, we have to remember that they run on the principle of zero trust. Trust no one. Let's check the firewall rules on the pfSense and find out. Well, there is a port 81 rule. And how did that get there? If we go back to the port forward rule, you will notice towards the bottom a filter rule association. That automatically creates the matching firewall rule. But that still doesn't explain why we can't access the internal server. Something else must be blocking it. Once again, remember that a proper security policy is trust no one. With that in mind, what is another piece of AWS that controls network access to resources? If you said the security group, you are right. If we access to resources, if you said the security group, you are right. If we look at the SG for the firewall, port 81 is not listed. As you know, there is an implicit deny all statement on the SG. Let's add Now we get the infamous WordPress installation page. Like I said earlier, placing a firewall in between internal and external networks is a lot more complicated than just spinning up EC2s in a default VPC. It takes a lot of steps, and they usually have to follow a certain order. We at least highlighted 3. We need a port forward statement, a matching firewall rule, and a matching entry in the security group for the firewall. Now, once you're done,